All right, we're going to do some more solving trig equations. Really, you've done this already. It was in the first few days, but those equations, we only gave angles between 0 and 90, whatever our calculator gave us. Our calculator can only give us one angle, so it's smart, but it's not super smart. We have to help it in order to get the correct answers. We talked about angles in standard position that are bigger than 90. We've talked about when we get a positive sign and positive trig ratio and a negative trig ratio, which quadrants that happens, and we've actually found the ratios. So now we want to be able to use, this is really going to help us with using our calculator and figuring out what makes sense. So first it says state the value of each to 4 decimal places. So just get your calculator out. Remember, make sure it's in degree mode. And you're going sine of 40. I'm just going to do them all at once. Cosine of 40 and tan of 40. And to 4 decimal places, the first one would be 0.6428. So 0.6428. Okay. Next one was 0.7660. And tan was 0.8391. Okay, so now we're going to complete the following table for the 4 quadrant angles that have a reference angle of 40. Round the trig ratios to 4 decimal places. So a quick little diagram. So basically here, I'm just going to, oh, that's not what I wanted to do. Okay, just give me a sec. I'm going to do, just quickly do a diagram, X and Y axis in each one of these. Okay. And so if we have to have a reference angle and our terminal arm has to be in the first quadrant, so I'm going to do all of my diagrams first basically to get them all done. So initial arm and then 40 degrees kind of about there, terminal arm. If it's in the second quadrant, so initial arm and reference angle of 40, so it would be in the second quadrant like that approximately. Then initial arm and then the third quadrant, so something like that. And then the fourth, something like that. Okay. And then when we actually show the angle, so it's just there. Oh, it's in blue. Anyway, that's okay. That's your angle. That's your angle theta, right? So this is theta. This is your angle here. This is your angle. So these are, I mean, there's coterminal angles to that, but we're keeping it between 0 and 360. Okay, so quadrant angle theta. So that's going to be the same. If it's in quadrant 1, then it's an acute angle. It doesn't change, right? The reference angle is the quadrant angle theta. The next one would be 180 minus that reference angle, right? Because this is 40 in here. This is 40 in here. This is 40 in here. Okay, so that would be 140. This one here would be 180 plus 40, which is 220. And this would be 360 minus 40, which is 320. Okay. So now when we get sine, cos, and tan, well, for 40 degrees, we already did that. Okay, so you can just copy down from above. So 0.6428, 0.7660, 0.8391. So now get out your calculator. And now we're going to do sine, cosine, tan of 140. So sine of 140, cosine of 140, tangent of 140. Okay, so 0.6428. So this one is the same as the previous. Then cosine is negative 0.7660. Okay, so now that's negative compared to the original. And then negative 0.8391. Okay, and that kind of makes sense. So in the second quadrant, cosine is going to be negative. Okay, tan is going to be negative because the only thing positive in the second quadrant is sine ratios. All right, so all are positive in the first quadrant, just sine in the second quadrant. Then get your calculator out, clear off, and now let's do sine, cosine, tan of 220. So that's going to be negative 0.6428. Cosine is negative as well. And tan is positive. Notice how the digits are all the same. It's just one is positive, one is negative. That's because they all have the same reference angle. Then do it for 320. Okay, so sine is negative, cosine is positive, and tan is negative. Okay, so it says, next part, what do you notice about the sine of the four quadrant angles and the sine of the reference angle? Is this true for the cosine and tangent ratios? So notice that they're all the same digits, okay? Just in the first and second quadrant it's positive, in the third and fourth it's negative, okay? So if you, we've talked a little bit about absolute value, not a whole lot, but basically the absolute value of your angle, sine of theta, is equal to sine of the reference angle. Okay, sine of the reference will always be positive because it's in the first quadrant. The angle theta that has a reference of theta r, the value will be the same if we take the absolute value. Okay. So in general, for any reference angle, theta r, the four quadrant angles are the original in the first quadrant. Then this one here is 180 minus theta r. This one here is 180 plus theta r. And this one here is 360 minus theta r. Okay, so when we take the 180 and subtract your reference angle, that's your theta, right? So this is really theta. Absolute value of that will be the same as if you do this one. So these would all be considered theta, but separately. And so they're all equal to each other if you take the absolute value, because that just changes it to be positive. Okay, and the sine of the reference angles are always positive because they're first quadrant angles. Here we've put in there all our positive, sine is positive, tan is positive, cosine. So remember, it's all students take calculus. It's the cast rule, okay, or add sugar to coffee. A few different ways of remembering it. So we can use these relationships and the cast rule, that's that diagram up here, to solve trig equations. Solve each equation for theta, where theta is between 0 and 360, and round to the nearest tenth. Okay, because there's always going to be two possible solutions. Okay, so we're going to first look at sine theta equals negative 0.9659. So the related equation, so change this. So instead of theta, it'll be sine of the reference angle. Well, that means it'll be positive. So in order to get the reference angle of any angle, your ratio has to be positive, right? Because that will give you an angle less than 90. So then what's your reference angle? So here you want to go second sine of positive 0.9659. Okay, and we'll round to, it says nearest tenth, but this actually, nearest tenth goes to 75.0. We'll keep it as 75. Sine of the original trig ratio is negative. So possible quadrants are the third quadrant and the fourth quadrant. Okay, so these two quadrants here. And so the angles are going to be 180. In the third quadrant, we would add the reference angle. So that's going to be 255. In the fourth quadrant, we'll take 360 and we'll subtract 75. That's 285. And then we just list those two. Those are our solutions. So often we use squiggly brackets, right? So the next one is a cosine. It's positive, so really it doesn't really change, but that will give us our reference angle to help us with the other quadrants. So now the reference here will go second cos of 0.4581 is 62.7 degrees. Where is sine positive? Oh, so it's positive. Where is cosine, I should say, positive? In the first quadrant and the fourth quadrant. So if it's in the first quadrant, nothing changes. The reference angle is the same as the angle. And in the fourth quadrant, it's 360 minus 62.7. So you can just go 360 minus that angle, and that's 297.3. And those are your two solutions. Okay. Then tan, so reference angle, we make the ratio positive. All right, and then we're going to go second tan of 0.7904. And that nearest tenth is 38.3. Okay, the sign of the ratio, SIGN, of the trig ratio is negative. So when is tan negative? It's negative in the second quadrant and the fourth quadrant. So in the second quadrant, with a reference angle of 38.3, that'll be 180 minus 38.3. So 180 minus that answer, 141.7. And then in the fourth quadrant, it'll be 360 minus 38.3. So that's going to be 360 minus 38.3 is 321.7. So those are your solutions. Okay. If you were to go, for example, let's do, if you didn't do it this method, you'll get one of the angles for sure in your calculator. So if I did tan, so second tan of negative 0.7904, I get a negative 38.3. All right, well, you're asked to give these angles between 0 and 360. So that's not going to be your answer. You would then have to convert that to an angle between 0 and 360. So by adding 360 to it, coterminal angle, then you get 321, which is this one here. Okay, so it's always going to give you the smallest angle that's closest to 0, whether positive or negative, if you think about it that way. Okay, so this way we don't have to work backwards from negative angles, which is kind of nice. We can just use our reference angle to get them. So it says solve each equation for theta, round all answers to the nearest tenth. So now that we've learned about this, and it says between 0 and 360, that's when we have to think about it. This is kind of like in the ambiguous case when we're dealing with sine law and finding an angle. We always have to look for two of them. So here, so really in your calculator, so this is positive. So I'm just going to go, right, this is what you're going to enter. Okay. Because it's positive, so really this is, so sine, you can show it as sine reference angle, 0.4672. So now the reference is second sine 0.4672 is 20, nearest tenth, 27.9. Okay, then where is sine positive? In the first quadrant and the second quadrant. So this is in the first quadrant. Your other one is 180 minus 27.9. So in your calculator, just go 180 minus the last answer and 151.1. Okay. Next one, so again, that's a positive cosine ratio. So theta r, we will then go second cos of, 0.8982. 26.1. So, where is cosine positive? First quadrant and fourth quadrant. So this is in your first quadrant. Now your fourth quadrant, that's going to be 360 minus 26.1. Okay, so 360 minus that answer is 333.9. Okay. And then the last one here, so tan of theta r, well, not the last one in the row is 3.9095. So these were all positives. So your calculator, you don't have to do any work really to get at least one of them correct. So we're going to go second tan 3.90, 095. Okay, so that's 75.7. Now where is tan positive? First quadrant and third quadrant. So we've already got this one, and then we go 180 plus 75.7. So we're just kind of tying in all of the last few lessons into this. Okay, so then that angle plus 180 is 255.7 degrees. Okay, now we get into some negatives. So this is where we're going to, it's really beneficial to change it to be a negative ratio to get the reference angle. So sine of theta reference equals positive. So theta reference equals, so second sine 0.2915, and that's 16.9. So where is sine negative? In the third quadrant and the fourth quadrant. So this is not one of our answers. So I'm actually going to not put a comma there. Now that I'm looking at this, when I go back up here, this was our reference. So I should really state this a little bit better. So here, now, I'm just going to do a theta equals 75.7, comma, 255.7. Here, the reference, so theta equals 26.1 and comma this. Same thing here. That's your reference, so theta equals 27.9, comma, and then this angle. So I should have done a better job at my notation in the last part. Okay, so then here, there's my reference. And so theta then equals, so it's going to be, in the third quadrant is 180 plus 16.9. And then 360 minus 16.9. So I have to do two calculations. So that simplifies to 196.9. And what's that? 360 minus that answer is 343.1. Okay. So then this one, cos of theta reference is equal to the positive ratio. So theta reference equals so 78.8. So now I'll switch to red, keep it consistent. So theta equals, actually I got to think about in my quadrants here, where is cosine negative? In the second and the third. So now when I go to do get my angles, it's got to be 180 minus 78.8, and then 180 plus 78.8. So to summarize, that's going to be what, 101.2 and 258.8. Okay, then F, so tan of theta reference equals the positive ratio. So theta reference equals, so this is 0.653, so second tan 0.653 is 33.1. Okay, so then, I have to do where are they located. So positive tan is in the first quadrant and the third quadrant. So that means 33.1 is one of our angles. And then the other one's 180 plus 33.1. So that is, what's that? 213.1. Okay. Then question 2. Let me just move. Can I move this a little bit? There you go. Question 2. The terminal arm of theta passes through the given point. Sketch the angle and determine the measure of theta. Round answers to the nearest tenth. So in this case, you're only giving one angle, right? But you'll have to do a little bit of work. So, okay, didn't want that, sorry. Okay, so want just a coordinate grid. Then our point -5, 3 is, sorry, -5, 3 is there. So then our, if we graph our initial arm and our terminal arm, okay, and then we can plot or just draw your triangle, right? So this is -5, this is +3, this is theta. So theta, the terminal arm passes through the given point, sketch the angle and determine the measure of theta, round to the nearest tenth. So really what we want to do is think about this reference angle in here. So we can use whatever trig ratio we want, but because we're given the x and y, why bother calculating the hypotenuse? Let's use tan. So tan of theta is equal to 3 over -5, okay, which is equal to -3/5. But let's do the reference angle. So tan of theta reference equals +3 over 5. Okay, so then in our calculator, we're going to go second tan +3 divided by 5. Okay, and that is 30.96. I think it said round to the nearest tenth. Let me just, yeah. So that's going to be 31.0. Let me just check that. Yeah. Okay, degrees. So that's your reference. So normally we'd get two angles between 0 and 360, but there's only one here. It's in the second quadrant. So therefore, theta is 180 minus that 31.0. So what is that? 149 degrees, I should say. Okay, so you can go back and put 149 degrees. So next one, same thing. Coordinate grid, XY axis, then plot -2, -4, so kind of about there. Graph your initial arm. Graph your terminal arm. Okay, you can go through it if you want, right? But you're going to draw your triangle. Okay, up to the x-axis. So there's your angle theta. And then this angle is your reference. Okay, point, so that's -2 and this is -4. So tan of theta is -4 over -2, which is 2. Okay, and so our reference angle, we'll get that, is going to be equal to 2 here. So in our calculator, second tan of 2 is 63.4. So notice how here, if I had just solved this to get theta, I would get 63.4, but that's actually not what theta is. So that's why I changed it to the reference angle. So reference is 63.4, so theta is 180 plus 63.4 because it's in that third quadrant. So that's 243.4. Okay, so you have to think about where the angles lie so that you can get the right measure, because your calculator just gives you one of them. Okay, so not all of them. You've got to be careful about that. Okay, and that's it. The answers are at the bottom, so hopefully I did them correctly. You can check them out and let me know. All right, we're done.